This lab is called the effect of dilution and common ions on the ionization of strong and weak acids. There's also a later part which is on the Ka of chloroacetic acid, but we'll get to that later.
Today we're going to look at the effect of dilution on strong and weak acids. So let's review what we're going to do first. According to the directions, and you can look at those as well, we're going to take hydrochloric acid, which is a strong acid, and it's 0.1 molar. And I'm going to put a little bit in a beaker. And then I'm going to take this and do a series of dilutions.
In the lab today, we'll be making something called a serial dilution. That means that we're going to dilute by a factor, in this case 10, and then we'll dilute again by that same factor. You could do this many times, and that way you could go from a very concentrated to a very dilute solution, where you wouldn't be able to do it in one step because that would require taking too small an amount of the concentrated solution and diluting it, so it wouldn't be precise. So we're going to do a serial dilution in this lab by 2 factors of 10, starting with 0.1 molar HCl. Okay, again, it's a stepwise dilution. We're going to do it with the HCl, and then again with the 0.1 molar HOAC.
I'm going to reduce the concentration of the HCl each time by a factor of 10. Then I'm going to do the same thing for acetic acid, which is the weak acid. I'm going to make the dilutions, and we're going to measure the pH of each of these solutions and record that in our data.
Hi, so I'm going to do the serial dilution. So we have some 10th molar HCl in this flask, and I'm going to take and pipette 5 milliliters of it. Hold it up to eye level. There we go. Into this 50 milliliter volumetric flask. So, you'll notice that I had a 5 milliliter pipette and a 50 milliliter flask. So you can figure that that is a factor of 10, tenfold dilution. Because now I'm going, eventually I will add water to this. Okay, so that's 5 milliliters placed in a 50 milliliter volumetric flask. And now I'm going to add water. I think I'm going to go get the distilled water bottles that come out much slower so I don't make a mess of it. Now I will try to fill it to the mark, which is pretty high on the neck on this one. Okay, good. And now, like you always do, you invert it 10 times. Let the bubbles go through, and that's how you make sure you mix it. 5, 6, 7, 8, 9, 10. Okay, so when I put that 5 milliliters in here, okay, I added water to it. I didn't add any more HCl. So the amount of HCl in here is the same that was in the 5 milliliters, but now it has a volume of 50. That's why it's a tenfold dilution. So now I'm going to take a clean pipette, and I'm going to now take 5 milliliters of this solution and dilute it again by a factor of 10. Keep track of my caps here. And get 5 milliliters here. Oops. Good. These pipettes are what we call to deliver, which means we let all of the liquid in them flow out. If there's a hanging drop, we leave it. That's the way the pipette is calibrated. I'm just going to leave it. Now I take it out. Okay? Now again, I'm going to dilute this with water. and I want to get it right to the mark. So I'm going to use this bottle. Oopsie daisy. Okay, there I am at the mark, and do you see the cap? And I'm gonna invert and mix it 10 times. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I have 10th molar HCl. The first dilution, which you will have to calculate what the molarity is, and the second dilution. And I'm going to transfer some of each of these into these 2 beakers, and then I'm going to measure the pH. Previously, I actually calibrated the pH by using 2 different buffer solutions, so I know that it's going to give me pretty accurate readings. That's probably enough. Okay, so I have my 3. So now I'm going to take this is called a pH probe, or a pH electrode, different names for it. And I'm going to rinse it with lots of water. Water is cheap. Distilled water. Okay, so now I'm going to put it on, turn it on. I'm going to measure the pH of the 0.1 molar HCl solution. And we want to stir it a little bit, kind of make sure that you have a stable reading. And even you might know theoretically what this number should come out to, but when you work in a lab, you don't always get exactly what you think you should get theoretically. Although this time it worked out pretty well. Okay,
Looks
so moving
excellent.
right along, I am going to now rinse this. Now my acid is getting more and more dilute. So I better use a lot of water here, because if I get an extra little bit of concentrated HCl, I could change the pH a lot. So I hope I did a good job rinsing. So now I have my first dilution. Get this out of the way. I think it actually needs a little more. That's the right one, right? I'm just going to pour it all in here. Make sure it's high enough. Ugh. Okay. Let's let it. Sometimes if you with this pH meter, it should give a beep. Okay, 1.97. So I hope you're recording that data on your data sheets. The first pH was 1.00 for 10th molar HCl, and now it's 1.97 for the first dilution. Okay, now again, I have to rinse this very well. I probably should have measured the least dilute one first.
The most dilute.
I'm sorry, the most dilute one first. Yeah. Okay. So now, I'll take this beaker with the second dilution. And let it sit for a few minutes, or a few seconds, till it beeps. Oh, it looks like it's pretty steady at 2.97. There's the beep. Okay, 2.97. All right. Okay, so now I'm going to do precisely the same thing, except with a weak acid, acetic acid, which we call HOAC. Oh, here it's labeled acetic acid. Okay, and it's 10th molar. So I'm going to put some in this flask. And then I'm going to do 2 dilutions again, same type of dilutions. I'm going to use 5 milliliter pipette to pipette 5 milliliters. Put it in a 50 milliliter volumetric flask. That's what this is, with a long neck. Those are flasks we use for dilution, because we can get the volume pretty precisely with that long skinny neck. This one isn't cooperating too well. I don't like those other devices, but this one can be pretty annoying too. All right, good, that's how it worked. 5 milliliters in here. Into a 50 milliliter volumetric, which then I will fill to the mark with water. Okay. Water. Oh, I have another water bottle down there. Thank you. Almost there, so I'll use the smaller one that comes out less quickly. Good, right to the mark. And now invert and mix. 1, 2, 3, 4, 6, 7, 8, 9, and 10. Okay. And now I will take 5 milliliters of this with a clean pipette and put it in the next flask. It's labeled second dilution. Oops, not working too good. I can tell there's not a very good seal. I have to push it hard to keep the seal. Good. Still coming out. All right, just leave the last drop. And now I dilute it. We call it, like I said, a 10-fold dilution, factor of 10 dilution. 5 milliliters diluted to 50. Get that to the mark. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I'm going to pour each of these into a beaker. So that's the second dilution. This is the first dilution. And this is the original, okay? And again, I'm going to have to rinse it with plenty of water, this pH electrode. Don't be stingy with the water when you do this in real life at some point, which I hope you get the opportunity to do. Now we'll put it in the 0.10 molar acetic acid. Do you remember what this reading was for the HCl? The 0.10 molar HCl? If you remember, it was 1.00. This is 2.84. So what does that say about acetic acid at the same concentration as HCl? Is it more acidic or less acidic? 2.84. Write that on the data sheet. Okay, now I gotta rinse again. Second one. First dilution. Well, let's see if we can get a beep here. Looks like it's pretty steady at 3 point, oh, it just changed a little. Did you hear a beep?
Yes.
3.42. Okay. Rinse it again. And now the third solution, which is the second dilution. Spilled a little bit. Let it stand.
There we go.
3.90. Okay. So that's what we have for the diluting a strong acid and diluting a weak acid. And I believe you will have some discussion and calculations and figure out, why they're different for the strong and the weak.
In the next part of the lab, we look at what happens when a common ion is added to the HCl solution and to the acetic acid solution. So first, I'd like to explain what a common ion is. Okay, well, you see here the dissociation of HCl. It produces H3O plus and Cl minus ions. We call that chloride ion a common ion because it's an ion that the HCl has. So it's an ion common to the HCl. When we add this ion, we want to know, does that have an effect on the pH? Similarly, for the weak acid equilibrium of HOAC below it, the common ion to HOAC is acetate, OAC minus. So we will see what happens when we add acetate ion to a solution of acetic acid. Does that affect the pH? The source for the common ion chloride is sodium chloride. So we will weigh a sample of sodium chloride and dilute it with 50 milliliters of 0.1 molar HCl. Similarly, we will use a sample of sodium acetate, which we will weigh out, and we will dilute it with 50 milliliters of 0.1 molar acetic acid to prepare the solutions for testing the effect of common ion addition on pH.
So first I'm just going to tear my beaker, tear the beaker. And the instructions say to weigh out about 0.29 grams. Oops, it's already too much. Jumping the gun, pulling too much. And getting a little closer. Almost want to call that a day. Oh. Good. Well, it's fine. I'll do it a little more. Whatever. All right, so that's 0.284 mass of NaCl, 0.284 grams. Okay, now I'll do the acetic acid, the sodium acetate. Again, I will tear this. Okay. And now this is supposed to be between 0.68, around 0.68. So break this up a little first. Oh. Hmm. 0.684. And this is actually sodium acetate trihydrate. This is simply sodium chloride. But this is NaOAc.3H2O. But if you were going to calculate the molar mass, OAc is CH3COO minus, which is C2H3O2 minus. So sometimes chemistry is more complicated than meets the eye right away. And this is what you would have to do to calculate the molar masses. You'd have to take into account the 3 moles of water. Yeah, if you looked up O and element AC, you would actually get the wrong answer. Okay, so I've got the correct masses now. I'm going to go back and put in the 50 milliliters.
So here's the 50 milliliters of each acid, and we're going to use it to dilute first of all, the sodium chloride and the HCl. And just used a graduated cylinder.
So this is HCl in here.
Yes.
50 milliliters. Pour it into the beaker with the NaCl.
And then we want it to dissolve.
Yeah.
Naturally.
We'll check that out later. Let's do the next one.
Well, we're going to do the acetic acid and the sodium acetate.
This was the 0.1 molar, the original solution, before it was diluted.
Now we have our solution. Sodium chloride is dissolved in the original HCl solution, the 0.1 molar, and the sodium acetate is dissolved in the original 0.1 molar acetic acid solution. And Dr. Cooley is going to determine the pH of each of these beakers, what's in each of these beakers, and we're going to write that down as data. So she's going to rinse the electrode once more to make sure it's clean.
I'm just rinsing off the pH electrode. And here is the NaCl with HCl. I don't know if this is enough. Oh.
I think so. Okay, now you can see the reading of the pH. Let's wait till it beeps.
I should have put this in a smaller beaker.
It's beeped. It's 1.06 is the pH.
Okay, and now I'm ready to measure the solution with the acetic acid and the sodium acetate. The sodium acetate with the acetic acid is 4.60.
The final job we have in this lab is to measure the pH of a 0.01 molar solution of chloroacetic acid. And in doing so, we will be able to find the data we need to determine the Ka for this acid.
So there's only one thing more that we have to do in this experiment. And this is, it's really unrelated, honestly, to what we've just done. But what we're going to do is we're going to figure out the equilibrium constant for chloroacetic acid by taking a single measurement of its pH. Not the best method to do it, but that's what we're going to do. So I have 0.010 molar chloroacetic acid, which I have to be pretty careful with. And I'm going to take my pH probe out of the buffer. We'll learn what buffers are pretty soon. Really rinse my electrode because I want to get a good reading. And put it in here. And now you're just going to have to write down the number when we get the beep, when we get the stable value. Let's call it 2.47 as the pH of 0.010, 2.46, it beeped. 2.46 of 0.010 molar of chloroacetic acid. And you might want to compare that to what it was for acetic acid, and what does that tell you exactly? Okay? All right. And that's it.